Thank you for the great introduction. I'm really happy to be here. Thanks for the invitation. I think it's a great audience. We did a workshop yesterday. It was already a good start. So I'm going to tell you something about the Things Network, about our idea, the vision, the mission, and our strategy. My name is Johan Stokking. I am a co-founder and tech lead of the Things Network. And yeah, just something about myself. I started programming at the age of 12 in Turbo Pascal, and later switched to Delphi. I was, really great visual designer. And then I moved to C# development, focused on cloud services, and started building software for timekeeping for professional sports events. So I don't know if you guys ever heard of the sport speed skating, but it's really big in the Netherlands. Actually, it's the second biggest sport after soccer in terms of airtime. And I worked for the sports federations to build timekeeping systems, so hardware interfacing and stuff like that. But this is so specialized that it was really hard to scale it. So I had one customer that was the Royal Dutch Speed Skating Association. It was great, an awesome vendor lock-in. But yeah, you can't really run a company of 30 people doing just that. So I started thinking about that, and that was also the period where I just drank coffee with fellow entrepreneurs in Amsterdam, and one of them was Wienke Gieseman, and he just sold his former startup, was kind of a Netflix for art house, wasn't really a big success. So he was also looking for some new opportunity, and we were talking about this, and we were basically agreeing on the idea that we wanted to spend as little time as possible on something that would just generate a very basic income, to at least just cover the cost of life, just housing and some food, and that's it. And then hopefully in 3 months freelancing work, for example, to spend the rest of the time on something that could become really big. And so we were both working on organizing this, because in my case, for example, the speed skating, it's a winter sport, so it's actually only busy in September, October, November, and then December, and then the season goes, and then in the summer I had nothing to do. But yeah, it was great though. So that was also the period when we started talking, and also that Wienke had just been to a meetup, and it's the Internet of Things meetup in Amsterdam. It's a very big community. I think there are, you can see it, 3,500 people in there, and they are all interested in the Internet of Things. And Wienke went here, and he saw a presentation by KPN. And KPN is the big Dutch telecom operators, much like Orange in France, for example. And they were presenting about LoRa, and LoRa is this new Internet of Things technology. It's long range, low power, and it's designed for Internet of Things applications. It's long range because the frequencies are low. In Europe it's 868 megahertz, so it's low enough to get pretty far in dense urban areas, about 2 or 3 kilometers. And in rural areas, 10, 15 kilometers. We even did field tests with 70 or even up to 92 kilometers of reach. So that is great. And it's really intended to connect things. So, but things don't have an internet connection. They don't have, the internet protocol stack is way too heavy for most things. So this is basically a very simple protocol. It's just based on the most basic version is that a device just sends a message, it's encrypted, and it's picked up by gateways. It's like hotspots, and they have to find out whether this message is intended for their network, if they have the right security keys to decrypt the message. But it's really intense for the network to handle the data, but the device doesn't have to do anything, just a matter of sending very simple, small packets. And that makes it great for low-power applications. Back then, the alliance had just formed, the LoRa Alliance. And the telecom operators like Proximus in Belgium, KPN in the Netherlands, and Orange in France, and some other around the world, they were the founding partners. And for us, that really helped because they are the market makers. We never had to explain anybody what exotic technology we were using, because we could always say, yeah, telecom operators use this as well. So this was really a technology enabler for us. And if you look at some of the capacities, it has you can connect it depending on the behavior of the devices, but you can connect about 10,000 devices on one gateway. It's super low power. So many devices can run on solar panels or with a battery that you don't have to replace that often. And it uses the unlicensed spectrum. So it's what we know as the ISM bands, for example. In Europe, it's 433 and 868, and US and Asia, it's 915, and the LoRa Alliance defines the frequency plans to use, but you don't need to have a license to send and receive data. And the protocol is open, so everybody can implement a network server. So the reach is long, and also it's a radio protocol. So as you can see in this image, this is Amsterdam, and we have in our Rockstart building, that's the co-working space where we are located. We have a gateway on our roof, and it works really well, as you can see. And as you can also see, is that so those blue ones, those are gateways in Amsterdam, and there are also some devices that send something that are its message is picked up by two gateways, and that is because it's a radio protocol. So as long as there's a gateway in reach, it receives the message. And that makes it also, there's no pairing, there is no handshake, there is no connecting like Wi-Fi or Bluetooth, it's super low power. So I met up with Winke again, and he basically asked me, can we do this? Because yeah, he's not really a technology guy, and I was, but not really in Internet of Things. So we had to look into it, and we basically thought, okay, we should do this. We should try and implement this protocol and see how far we get. So 2 weeks later, I was going on a trip. It's called Hacker Paradise. It's a traveling community for developers. And I was going a month to Barcelona, bringing my work and connecting with like-minded people that came from all over the world that were working on their own projects. And we did many things. We worked, but we also ran with the bulls in Pamplona, for example. And I was every day on the phone with Winke just to talk about our idea. And then we formulated our mission. So this was the initial plan, to build a decentralized, open, and crowdsourced Internet of Things data network that is owned and operated by its users. So we thought what to do with this. And you know, the lean startup, all the principles about starting and bootstrapping a company are saying, you know, you have to validate early. So we took this sheet and we went to the same Internet of Things meetup where we learned about this technology, and we pitched it. And I was in Barcelona. I was on Skype, so I took this screenshot. This is me from his laptop looking at the presentation. I could hear all the questions by the other people. It was really cool. And we invited the people that were there in the audience to come by the next day if they were interested, to think about this idea and if it was technically feasible. So the next day we were at the office. We were sitting here, and I was again on Skype, and yeah, we had a group of random people. We had a electrical engineering student. We had a math professor. We had a police officer. We had a guy that was working on a 3D printing company for jewelry. But everyone was, you know, interested in this project. And the next step was, of course, to start prototyping, to build the network. So that was, you know, something that I started working on as a software developer. But since we didn't have any legacy, we basically could do whatever we want, any language, any platform. And I had a background, like I said, in C# and .NET development, but yeah, as you all know, that's not really very popular in open source communities. It's getting better recently, though, but And I also wanted to learn something new, so I just looked at a website. It's called github.info, and it has the statistics about GitHub, and it tells you something about the popularity of programming languages. And so yeah, there were a couple of alternatives, and then personal likes and dislikes, and eventually we chose for Go. It's a language designed by Google, introduced in 2009. If you don't know it, for example, Docker is built in Go. And my flatmate in Barcelona, he was a Go developer that also helped, so I could just ask him day and night any questions about Go. And it's open source, it's reliable, it's efficient, so it was great. So we started building, and Luke, that was my flatmate, a British guy, came up with the very good name, Croft. So we had a project that's called LoRa Croft, and we started prototyping the backend. So we had the PDF, the LoRa 1 specification, and we knew what the bytes meant, but we didn't have a gateway, so we had to configure the gateway over SSH remotely because we had it already in Amsterdam, but we were in Barcelona, we didn't have any devices, so we were asking people in Amsterdam to press buttons to see what happened, so it took some time. Actually, Croft is still online today, not that often, it's not too stable, but we gradually moved to a new backend, fortunately. And at the meantime, Wienke started to reach out to businesses in Amsterdam because we didn't want to buy the gateways ourselves because, yeah, that would cost us 15,000 euro. And it would be much cheaper if the people would actually buy them themselves. So he called companies that we worked for, companies that had a good location, like roof access, that would be a perfect location for these gateways. And they basically all said yes. So this was the idea, to cover the city of Amsterdam with just a couple of gateways and spread them around the city. We didn't know anything about coverage, about the properties of LoRa, about the influence of buildings. So yeah, we basically just started, and we wanted to have a prototype. We wanted to have a prototype use case. Well, we are in Amsterdam, so there are many canals with small boats, and they often they have leakage. They have water in the boat. So we thought let's build a use case for that. So this is a typical example of a boat in the canals of Amsterdam. So it would be a water sensor that would send a message to the owner when the boat was running water. And then the owner could, go there or get it cleared by a company, because there are actually companies for that in Amsterdam. So we started prototyping, and it worked. So this is in Dutch, but this slide basically says two things. One is that we were working late. That was always the case, and second is that it worked because this message says in Dutch that your boat is running water. So from those 6 people that were at the table, we started, growing and sharing our ideas, and then we decided to do a launching conference, like a real The Things Network launching conference, August 27th, 2015 in Amsterdam. It's a 17th century ballroom that is still original. It's a meeting room at the back of our office. There were 200 people there, not enough seats to sit, so it was great. And this is Wienke and I during the conference, and we had invited people to talk about Internet of Things, about use cases, about possible new things that you can do with LoRa. It was a really interesting day. And what we did in Amsterdam was more like a recipe. We wanted to kickstart the Things Network in Amsterdam with what we did, but everybody could start something similar in their city or area. So that's what happened. So over time, communities started to pop up, and it was real organic growth. It was great. But for scaling in the pace that we wanted, we needed to have cheaper hardware, because the gateways that we were using, they cost 1,200 euros, and that's especially for individual hackers. It's pretty expensive. So we decided to do a Kickstarter campaign for our own hardware. So that's what we did. We had 3 products: the gateway, development kit, and a node. And the gateway would cost 200 euro, and the development kit 400. It's an Arduino compatible board with a LoRa modem on it. And the node is like a small push-button device, and you can program functions to it, and it has some sensors in it. And we did the Kickstarter campaign to validate, of course, a crowdsourced model, because our mission was, we build an open, decentralized, crowdsourced Internet of Things data model, but if you have a crowdfunding campaign that doesn't work, then you're not really good at being crowdsourced. Also, it's a very good marketing channel. Everybody knows Kickstarter, and it generates some working capital. So yeah, so that's what we did. We set the target at 150,000 euro, which was just a bit more to make it financially feasible. And in 8 days, we met the target already out of 30 days, and eventually we had almost twice the target that we were aiming for. So that was a really good validation for us, and we are currently working very hard on these gateways. We have a joint venture with a product agency to build the actual hardware, and we take care of the software and the marketing and everything. So we're almost ready for mass production. And Kickstarter is an international platform, and we had 36 countries where the backers came from. So that was really good. And this is a very recent photo of the actual hardware. This was taken last week, and this is what it looks like when you place it inside. So next to building hardware, what else do we do? Because my initial idea was not to get in the hardware business. Hardware is expensive, it's risky. So on the software side, what we build is a backend. And the gateways, they communicate directly with the backend, and the applications of the users also talk with the backend. So it's the same backend, it's just routing messages. And this is basically how it works. So you have gateways, they have a certain reach. There are nodes, devices in that reach, and some devices are covered by multiple gateways. And the routers, they talk to the Things Network backend. Well, we wanted to do this decentralized. It's more like a star of stars network. Sounds still centralized, but actually these private networks, that's what you can install the backends yourself, because it's open source. You can also connect them with each other. So you can. This is like a central service discovery that we provide, but that's optional. You can have your own closed private network with your own gateways, your own applications. But you can also connect your private network to the community network, or you can just buy a gateway and connect it directly to the community network. So between the Things Network and the applications, there is some middleware required. And because there are many Internet of Things data platforms already, we thought it's not really a good idea to spend our time on that. So instead, we built integrations. So what the Things Network ultimately delivers is raw data on an MQTT broker, and we use Eclipse Mosquito for that. It's a great product. And we built integrations. So these are the ones that we are planning to build. So of course the 3 commercial ones, that's where most corporates are interested in. And mostly it's like a bridge from MQTT to another MQTT broker, or from MQTT to AMQP, sometimes with an SDK, sometimes just changing the security model. Amazon Web Services has device shadows, for example. That's things that we support today already. But the integration is synchronization of devices. So we have to know the devices to find the right encryption keys. But you also want to register your devices in your IoT cloud platform. So these should be synced. And then, of course, there is data back and forth because you can actually talk back to your node as well with LoRaWAN. And there's a lot of metadata that is interesting. So we wanted to do this open source, and the reason why we wanted to do this open source is that we believe that that is the only way to really make this big. And I think that, you know, 0 is a magical number. If you have 0 friction, 0 costs, then, you know, magic things can happen. So we want to be the most accessible solution for building a LoRaWAN network. And we're also planning to have a more protocol agnostic interface. So you can also connect Bluetooth devices or even IP connected devices to it. But we start today with LoRaWAN. And for us, it's not really about having a big share in this space or have a big commercial market share. What we are most interested in is to have a presence there, but to enable this pie to become big. So that is what we are working on a daily basis. And so how do we do that? We enable the building and the sharing in the economy, in the community. And so we let the people to communicate on a forum, on a Slack. We have a wiki, and we enable them to connect locally. So we have a community portal that you can find people in your own city or your own area. You can connect with them. You can join these local communities. So that is connecting locally. They have local meetups where they talk about Internet of Things and about Things Network and placement of gateways. But we also want to connect them globally. So if somebody is interested in specific applications, then you wanted to connect them with somebody in South America who's working on the same solution, for example. And what we really see our role is to get people started. So teaching them, doing workshops, guide them to building good solutions that make use of LoRaWAN or Internet of Things devices in general, so the connectivity layer. And of course, we share our vision. So we do a lot of talks and events where we go to, like this one here and many others. That's also great. So we also have the Things Network Labs that basically enables the third point. So connecting people globally. So the Things Network Labs is a website where you can create a group and where you can share ideas, could be business-wise or technology-wise, about some specific subject. So, for example, there's high water here in France, but yeah, that's also in Oxford. So Oxford already has a great monitoring system for the water level, so you can easily get in touch with them on the Things Network. It looks like this. This is the hardware that they're using in Oxford, and they have a great map with real-time statistics. And this could be really useful to use in France as well. And this is something that we enable on our platform. So we have a lot of communities. Today, more than 170 communities. And they are spread all around the world. And we want to give every community a face. So they are the initiator of their community in their city or in their area. And they organize meetups. And one of the, so this is, we are spread around the world. It's currently super concentrated in Europe, but in different countries in Europe. And we start to get more and more traction from all around the world. So that's really good. One of the communities is the Things Network Brazil. They have their own Facebook page. We have they use a logo that is that's our logo basically, and that's really cool. They organize meetups. They have the Things Network T-shirts. We never actually met these guys, but they are working on the same. They are really contributing to the community. That's really cool. This is also another example. They were installing a gateway. And that is how it goes there. They just buy a gateway, put it on a rusty metal pole and on a balcony somewhere, and they make it work. They create coverage, and they use the Things Network backend, which we're also deploying there in South America. So So who are these people? Who is in our community? Well, we have 3 groups. We have developers, and for developers we provide a starter kit. It's the hardware, the same hardware as we had on the Kickstarter campaign. So it's a gateway, a node, and a development kit. You can also contribute as an open source developer on the routing services. Everything is on GitHub. And if you want to buy this hardware, you can buy it in the shop, but you don't have to use our hardware. You can also use any other LoRaWAN enabled hardware to get started. Second are the businesses. I think that if you're building a network, it's really important that you have continuity. So there should be money flowing in anyway. Businesses really see commercial use cases on top of this. So we really want to involve the businesses as well. And you see that in many communities that there are do-it-yourself people, open source developers, but also businesses that are interested in solving their business problems, but also maybe working on new products and services. And for that, we also have a business contributors program. So it's the same as with the community, but they can connect with each other and share ideas. And finally, the cities. So the city councils, the municipalities, people that work for a city, they often have access to great locations for gateways. And of course, because it's open source, it's way more accessible for cities and city councils to use the Things network than signing with a big commercial operator. So yeah, use cases, well, the usual suspects, parking spaces, well, we've got them all, but this is not really interesting. This is just more in the category moving forward and looking backwards. So, you know, Larry King with his radio microphone, the first television programs were more like radio shows that were basically a radio program with a television camera on it, and the first car were like carriages without a horse, and that is a lot of use cases today, and that's fine. I mean, it's just testing the technology, making sure that it works. But we are most interested in the real innovation. So what is really new? What is unique for this technology? And some things are really accessible already. Some things are you know, for example, the sewer system in Amsterdam, it gets pumped continuously, and the sewer company has a 10-year contract with the energy company to pump the stuff out of the sewer system, and that is fine. I mean, but if you look at the intraday energy prices, they fluctuate a lot. So what this company can do is, based on the energy prices and the levels of the shit in the sewer system, to you know, estimate when they should start the pumps and when not. So it could be that later in the day, for example, there is an expected storm going over Germany, and the energy prices will be negative because there was a lot of wind energy on the market. And that could be the time to start the pumps, and otherwise keep them silent unless the level gets too high. So those are things that are really accessible. It's implementable today. It's just a matter of deploying a lot of sensors and testing the model. But the real big impact, social impact projects are, for example, tracking wildlife. So protecting rhinos and elephants from being poached by tracking them, because turns out that the only way to really protect these animals is by following them. Anti-poaching units, they literally have to follow these elephants and rhinos to protect them from poachers. So you can do that, for example, by having a simple GPS tracker, so the anti-poaching units know where they are, and then you need a very secure and proven long-range, low-power technology like LoRa to do that. Another great example is, that is something that is actually a real project today. It's called Safecast. And Safecast is started after the Fukushima meltdown. And the Japanese government wasn't really into sharing information the days after the meltdown, how bad it was, what exactly was going on. And the people didn't have a lot of information, they didn't know what to do, and the Japanese government, they started to move people that were close to the meltdown to a place that was further from the meltdown. But as you can see, because of the wind, there was a lot of radioactive material blown into the land. So people were actually moved from a place where there was less radiation to a place that there was more radiation. So there was a big trust issue between the people and the government. And this is when Safecast started. So Safecast is a voluntary project. There is only one guy that works full-time on it. And they built a system to measure the irradiation. So this is a data set from June 7th. So it's super accurate. It's just only a few days old. And what it does is you see all the roads. And what they use today is a sensor. It's this device, and they mount it on cars and on small scooters, and it measures the radiation and the GPS location. It writes it to an SD card, and then somebody has to read from the SD card, and they do the extrapolation to get this. But this is, of course, a great use case for LoRa, because you can actually drop sensors. You can even drop it from a plane when just after a meltdown happened, to actually start measuring and to see what is really going on. And one of the guys that is an advisor to this project, and that is also the guy that contacted us and is actually has a working the Things Network enabled prototype, and he wanted to show us that, is Ray Ozzie. And Ray Ozzie is the former chief software architect and CTO of Microsoft, and he now spends his time on the good projects like these. And he said, you know, this is really a self-empowerment use case where you actually bring the power to the people because they can set up the network themselves, and you can't really take it down. And another thing, and that's also one of the things that I wanna close with, is a takeaway that he wanted to share with us, and that is like a tipping point that happened somewhere in the 70s and 80s when home soldering and mainframes came together. That was a real, a real tipping point when things got big. And everybody knows what it is. It's a personal computer, and he sees the same thing happening now with existing machine-to-machine and IP-based communication, which is heavy, it's expensive, it requires bigger batteries, but it works. It's resource-intensive, but the industry knows it. They have it. They have models for it already. They have applications for it already, but it's not accessible enough. And on the other hand, you have low-power wide area networking that is cheap, it has a long range, but it's not connected yet. And he said, you guys are exactly there. And that makes it really interesting for me to work on this and to build prototypes. So back to our mission. Our mission is to build a decentralized and open crowdsourced Internet of Things data network, and we enable the people to do it. We set the example, we guide them, but they do it themselves. This was a tweet from somebody probably here yesterday during the workshop. They share that it works, but they built it. The only thing that we do is we set the example, we guide them, and they share it. And once it works, you can really see it in their eyes. They say, hey, shit, it works. And I'm doing this myself. That's great. So that's the Things Network. You are the network. Let's build this thing together. Thank you.